Oh, all right. Okay, moving on. So we're going to be solving absolute value equations in this video. So 16 through like 20. So before we even start, I know we went over this in class, but just to reiterate, we know that absolute value is hopefully the distance from 0 or the distance between like numbers. And we know that anything that we put, any number, I'm just gonna write any number that is inside of the absolute value, right? Anything that is inside the absolute value, whatever is inside of the absolute value becomes positive. So if I had like -8 inside of the absolute value, that would equal +8. If I had +8 inside of the absolute value, that would also equal +8. So essentially, this applies to when we have equations as well. So if I have absolute values, my absolute value has to be the bars, the absolute value bars has to be equal to a positive, right? Yeah, so all that to say is that in this equation, we have our absolute value bars. It has to be equal to a positive number. So in this case, we have absolute value equal to a -8, which is not possible because anything that goes through the absolute value bars has to come out as a positive. So starting off, we have absolute value equal to a negative. That means there's no solution. There's no possible way to put numbers through absolute value and come out with a -8, okay? So this would be no solution. Moving on to 17. Okay, so this is a good example, okay? So going back to the idea that absolute value, whatever number, any numbers that you put through the absolute value has to equal a positive number, okay? However, so in this case, we have absolute value equal to a +3. That's good. That's possible. We have a positive absolute value equal to +3. Okay. However, what's inside of the absolute value can be either positive or negative, right? So to solve this absolute value equation, we're going to take the inside of the absolute value, right, which is 6b minus 15, and we're going to make that equal to +3, and the inside, right, 6b minus 15 can also be equal to -3, right? So we're going to solve both of these equations, and both of these solutions will be true, okay, and I'll just show you why. So looking at 6b minus 15 equals 3, this is a two-step equation. I want to get b alone. So I'm going to add 15 to both sides. And to get rid of this multiplication of 6, right, because 6 is being mushed against the b, I'm going to divide 6. So 18 divided by 6 is going to be 3. That's one solution, right? So let's see, when we replace this 3 into this equation, you got 6 times 3 minus 15. Let's see if that equals 3. So 6 times 3 is 18, minus 15 is 3, and the absolute value of 3 is 3. Yes, that works. Okay, so that's our first solution. Let's solve this other equation. Okay, doing essentially the same steps, adding 15, and then I'm going to divide 6, and I get 2. Now, let's put this into the equation, back into the equation to check why this works. So we got 6 times 2 minus 15. Okay, so 6 times 2 is 12 minus 15. That would be -3. However, the absolute value of -3 is equal to 3. So this is equal to 3. This does work. So both solutions work, right? So our solution would be 3 and or 2. Both are possibilities. Okay. Going on to 18. Okay. Here we have our absolute value, but we have some stuff going on the outside. Now, that's okay as long as we get rid of the outside of the absolute value first. Remembering that we can never distribute into an absolute value, okay? So how else might I get rid of this 5? This 5 that is mushed against the absolute value. Well, 5 is multiplying itself with the absolute value. So if I want to get rid of the multiplication of 5, I can just divide 5. And whatever I do to one side, I'll do to the other side of the equation, and I'm left with 0 divided by 5, which is okay. So this is equal to 0, okay? Now normally, from here to solve, we would take the inside, and make it, we would turn this into 2 equations. We would make it equal to a positive, and then make it equal to a negative as well. However, 0 is neither positive nor negative. So we actually only have one equation to solve. 2x equals 0. We would divide 2 on both sides. And this is okay. We end up with x equals 0. Okay? So our solution here would just be x equals 0. And that is all. Okay? So going on to 19. Okay, same process here. Got the absolute value of 4y minus 8 plus 10 equals 10. Now again, wow, I don't like this example. I'm going to do a different example. 1 second. Different example, just so I can emphasize what we're supposed to do. Okay. Alright, so we got negative 3 absolute times the absolute value 2u plus 4 equals negative 42. Now, before we can do anything, we have to get rid of what's outside of the absolute value. So here we have negative 3 mushed against the absolute value. Keep in mind, we cannot distribute into the absolute value, okay? So to get rid of this multiplication of negative 3, we're actually going to divide negative 3. Okay, and we get absolute value of 2u plus 4 equals to negative 42 divided by negative 3. It's going to be a positive 14. Okay, and now that this absolute value is equal to a positive number, we are able to take this inside, and we're going to essentially turn this into 2 equations. We're going to take the inside, 2u plus 4, and make it equal to positive 14. But we're also able to make it equal to negative 14. And then we're going to solve. 2-step equation, going to subtract 4 first. And then divide by 2, that'll be 5. And going to do essentially the same process to the other side. And divide by 2. Okay, so I got my two answers, 5 and negative 8. Whoops. Oh, sorry. This is 18, and negative 18 divided by 2 is negative 9. Negative 9. Negative 9. See, I should have not been rushing. Going on to 20. Okay, same process. Before we do anything with an absolute value equation, we do have to get rid of what's outside of the absolute value bars. So here we have 4 and plus 5. So if this were like two-step, right, we would get rid of this plus 5 first. So we're going to subtract 5. And we also have to get rid of this multiplication of 4. So we have to divide 4, keeping in mind that we can never distribute into an absolute value. Okay. Now that we've got the absolute value alone, the absolute value bars alone equal to a positive number, we can take the inside and essentially we're going to make two equations. We're going to take the inside and make it equal to positive 12. We're going to take the inside and make it equal to negative 12 and then just solve. Essentially, we have to do the same process of adding 6 and dividing 3. And we get W is equal to 6 and or negative 2. Okay, I think this is a word problem. This will be the last one for this video. Okay, so we've got, this is an absolute value equation, an absolute value word problem, right? And we're always going to follow the same, I guess, format or same form for absolute value equation word problems, right? So our equation is always going to be the same. It's always going to be x, or whatever variable you're using, minus, it's always going to be minus the average number that you're working with. So an average number is going to be equal to the number that the average varies by. So give or take more or less. And from here, we just read to find those numbers. We're looking for the average and the number that the average can vary by, okay? So a machine fills small bottles of glitter. The machine is set to fill each bottle with 2 ounces of glitter, but it is acceptable to fill each bottle with 0.25 more or less, okay? So I'm ready to write my equation. The average number is 2, and more or less the number that the 2 can vary by would be 0.25. So that's our first step. Okay, and now we're just going to solve this equation, right? So I've got absolute value equals to a positive. This is great. So now I'm able to take the inside of the absolute value, and essentially we're just going to make two equations. We're going to make the inside equal to a positive 0.25 and equal to a negative 0.25, and then just solve. These are just one-step equations. So we're just going to, add 2. Okay. Okay. And so those are the solutions, 2.25 and 1.75. So the smaller value of the two we say is our minimum, and the bigger value of the two we say is our maximum. Okay? And that's all. And then we just have to put that on a number line. So 1.75 and 225. Okay, so the minimum was 175 and the maximum, the bigger number, was 225. And that is our problem here. Okay, I will continue in the next video.